So wait for another 1 or 2 minutes, then we'll start.
Yes, sir.
Actually, after each session, it's taking some time for the converting for the recordings.
Yes, sir.
That this Zoom video recordings. So now, Devalina, we are supposed to discuss about the project. Now, what else you want to say?
Sir, just one part is remaining for the plots.
Yes,
how to
that first complete, that part first complete, then we'll go for the discussion. And if anything left, we can discuss at 7 to 8 at that time. Yeah,
Sure.
because today we have quiz. You just announce that one quiz is there. Or
Yes.
we'll just send you the Google link. So there you have to answer 20 questions, fine. And you can see the answer, result also there itself. And along with that one, I will give one feedback form at the end of the session. Fine.
Yes.
And you'll get the certificate within 2-3 days. Fine. We'll prepare the certificate and sign and mention. Just wait for another 1 or 2 minutes, then we'll start. Only 18 students have joined. Just wait for some time. We'll start. Then let us start. Okay. Now time is 11:50, so let us start so that we can complete it.
Okay, sir. Welcome back, everyone. So just recently we were discussing about, just in the last session, we were discussing about data frames. And we saw how we can index into the data frames, how we can access data present in the data frames. Yeah, so we can also specify the names for the rows instead of simply 0, 1, and 2. Like we have specified day 1, day 2, day 3 over here. And we can refer to the named indexes. Another thing, Bitrend just posted one code. I was not able to discuss it in the last session. So if we have a data frame like this, okay. If we want to access some of the values like myvar.iloc, and over here if we write 0 to 2, so it is something like a slicing operation. So slicing through your row indexes. So if we execute that, get something like this. So we have rows and numbers. We have the row number 0 and 1. So remember that when we were using range functions, or whenever we were trying to perform some slicing, then the last index, we were getting the value up to the last index. It was not inclusive. So similarly, within a data frame as well, we follow the same convention. We can also slice the columns. So now we are having all the columns visible. Suppose we want only the first column. So we can write 0. So now you can have only the first column, 0, apple, and the next row is orange. So a part of the table you are accessing over here, this part. So this is the way you can slice inside the table, inside the data frame. The first part is the specifications for the rows. See what are the rows that you want to access, what is the column that you want to access, so that you can write over there. Okay. I think some background disturbances are there, so apologies in advance. Just focus on what I'm saying, okay, in case there is any background disturbance. So this is how we are going to slice the data frame. Next, we are now going to load a CSV file. So most of the data sets that you will work on as a beginner, most of them will be available as a CSV file, which is like an Excel file, but these values are comma separated values. So these are present as a plain text, and it is a very popular format for storing data sets. So first of all, we have to specify the path where we have the CSV file. In your Colab notebooks, you have a particular folder, sample data folder over here. Just check for all of those who are working in Colab. Okay. Preferably try to execute this part in Colab, because a lot of things are there that we have to discuss today. So we have the sample data. Within that sample data, we have some files. You can see that these are data sets. This is available by default in Colab. So you don't have to load it. It is present in the environment. From there, you can take any CSV file. So I have taken the California Housing Training train.csv. You can see there are 3 dots over here. So when you click on those 3 dots, we have the options like download it, rename, delete, copy, or refresh. We are going to copy the path. Okay. So when you click on copy path, you have that path getting stored somewhere in your clipboard. So you can see that on pasting it within the code cell, you can have your path, the link to the CSV file. Just follow along. Okay. So you can store this CSV link in a variable called as path. Fine. We are going to use this variable, this path location, in another function, which is also present in pandas, to read a CSV file. So we can call pd.readCSV, specify the path, and it loads our CSV file as a pandas data frame in a Python environment. Next, we can even print the data frame. So you can see that the data frame got loaded, and now we can see the contents within the data set. So it has a total of 17,000 rows and 9 columns. So all of you, please try to load the data. If there is any problem in loading the data, let me know in the chat box. This is a very important step. Okay. It's working? Okay. I'll just give you a minute. Please load the data. Learn that how we are going to import data within your Colab notebooks. So suppose that these CSV files are already given in the environment. What if I want to have my own file? You have this option over here, this arrow like mark within your file icon. Using that, you can upload your own file. So I can choose, I have one data set. Okay. I think not this one. I'll delete it. But I have one data present as a CSV file. I can just upload it in the Colab environment. Yes, your drive will also work. We will see that part in the next step. So you can also link your Google Drive. You can load your data sets within your drive and then link it with your Colab notebook. And then you can directly load the files. So what happens over here is that this file that I just loaded, Bima Indians Diabetes.csv, this is the data that we are going to work with in our demo mini project. So this data set is a local file. So if we close the notebook, if we refresh it, this will just go, this won't be there. It will be recycled. It won't be present. So it is temporarily available. You can also work with that. You can just copy the path. I can write it over there, the path. And now I can load it. So here we have 767 rows, 9 columns. Okay. One thing which you can do is header equals none. What was happening that the first row, the data of the first row was being considered as the column names. We don't want that to happen. So for that purpose, we are writing header equals to none. Okay. So this is how we load one data set. Next, we have some functions. Like if we want to access just a snapshot of the data, we don't want it to clutter our outputs. So if we want to have like 5 rows, so df.head, head function gives only 5 rows at a time. So when we execute it, you can see that we have 5 rows available. You can also specify the number of rows within the head function. By default, it is 5, but you can write 10 to load 10 rows. So now we have a total of 10 rows from the data set that we just loaded. There's also an option that you can access the last 5 rows or the last 10 rows, that whatever you specify. By default, it is 5. So we can print that out as well. So these are the last 5 rows of your data set. We also have the option to print the information contained within the data. So this is a condensed kind of information available to us. We can print df.info. This tells us that what are the contents of a column, the count, and the data type. So here we can see that we don't have any null values present in the data set. So this is already pre-processed data. We don't have to worry about it when we work using any machine learning algorithm. This is already pre-processed. So we don't have to do the data cleaning or transforming the data or anything over here. However, when you work with real data, like the real world data, there you will find that a lot of time is getting consumed for cleaning and formatting the data and writing it in a specified manner so that you can load it and you can work on it. So over here we can see there are 768 values, means 768 rows. For each we have the data types. Integer, we have floats. Again, we have integers. So the summary is also given. Data D types, float, int. Memory usage is also available. what is the size of your data, how much, when you load the data in the environment, how much memory is getting consumed, that is also present. So a lot of information is given within the
Ma'am,
df.info.
ma'am, could you explain df.head and tail once one more time?
Yes, yes. So when we write the head function, it gives us a snapshot into the data set. So when you're simply writing, not printing, but just writing df.head, which means that we want to see what is the content of our data. It will access the 5 initial rows of your data. So if I print df.head, it gives me the 5 rows and all the columns. So all the columns will be included in your head function. So it returns 5 rows, 5 of the top rows of your data, and all columns, all the attributes which are present. When you are going to specify, like if I want, I can also say that I want to access some more data, I want to see other rows as well, so I can specify 10. So it will give me the first 10 rows. Head actually means the head of the data, like the starting of the data is represented as the head function. And if you want to access the last rows, for that you are using the tail function. So when we are saying that df.tail, so it is accessing the last 5 rows. Just like head was giving you the first 5 rows, this is giving you the last 5 rows. See, so over here we have the last rows, the contents. Similar to the head function, you can also access the last 10 rows. So you can specify it, or maybe just let's try with a different number. This time we access last 12 rows. So the last value that we have over here, this will be, it will feel like you're iterating it from the end. You are accessing all the columns from the end. So that is how it appears. Okay.
Okay, ma'am, it's clear.
Okay. Why we are setting the header to none? Okay. Just let me get back to the example. So try loading it without header equals none. The problem that occurs over here is that the first row of data that we have inside a CSV file, it is getting considered as the column names. So 6, 148, 72, 35, 0, 33.6, and so on. Whatever data that we have, it is part of our data, but it is being read by the Python interpreter as your column names to prevent that from happening, because usually we have the first row as our column names. But over here, we don't have that. We only have comma separated values, and all the values are contained within that CSV file. And there is no other specification for your column names. So to prevent this from happening, we want to include this data within our data frame. We write header equals none. And when we load that, we can see now this particular row is finally included in our data frame. I'll also share the drive link with you all. I have loaded that data for so I've shared the drive folder. What you can do is you can simply take that folder and click on copy to drive. So there's one option to copy to drive. Add shortcut to drive. Okay, so click on this one, add shortcut to drive, and you can just link that with some other folder, or you can just link it to the main folder in your drive. So there you will have your own applied Python folder in your present in your drives. It will be very helpful because all the Colab notebooks that we have shared, I was planning that I'll also provide the uploaded version of the notebooks in that one particular folder. So if you can just go to the Drive link and add that folder. Okay. So I think loading a data set, a data frame is clear to everyone. You've understood that part. A very small section is remaining where we will see how we perform some data visualizations. And after that, we will discuss about a mini project. So if there's not any query, I'll move on to Matplotlib. So Matplotlib is another library which is used to create data visualizations. In order to load Matplotlib, we have to access it through pyplot. So it is you can just follow the statement, import and the library that we have, matplotlib.pyplot as PLT. So load it in your Colab notebooks. After having loaded this, you can try having your own graph, have your own plot. Okay. So over here, we have defined two lists. The first list contains the values that we want on our x-axis. The second list contains the values that we want on our y-axis. We use the plot function. So this plot function is, available in your Matplotlib. So once we load our Matplotlib library, we can call the function using the PLT, the Matplotlib, the library that you loaded. So plt.plot, and you pass the values that we have for x and y. And then using the function plt.show, we can display the plot. So let me show you one. Well, so this is how a plot appears. So there is no defined relation between the x and y axis values. These are just random values. We just want to see whether we can create a plot or not. And we use the plot function. We pass the x and y values. And then we call plt.show. So if you don't use this function, the plot, this will remain as an object itself. But if you want to display it properly in your notebook, you have to use the plt.show function. I've shared the code in the chat box. Everyone, please implement it. Are you able to get the output to your plot? Please continue working on Google Colab. So that will give you the interactive ability. Yeah. Okay. Fine. What about others? Access error. Why? Can you share your code? Just copy paste it from the code cell. Saurav. Or you can try one thing. You can just copy paste the code that I just shared. Access error shouldn't be there, but if it is happening, then it means that either it is a problem during your the values that we have. So maybe while passing as well in the plot function, just share your code. For others, I'll give you another plot that you can work. So now that we have a simple line plot, we can also have something called as scatter plot. So what are the points, data points? So you can mark it in your graph. So plt.scatter will do that for you. When we have plt.scatter, then we are we are marking it, the x and y coordinates, we are just marking it in the graph. So over here, whatever values that we have, so here the coordinates follow as 5, 10, 2, 5, 9, 8, 4, 4, 7, 2. So let's get back to the scatter plot. Here we can see one thing which I can surely confirm, it is very obvious, 4 and 4. That is the first, that is one of the numbers that we have, the coordinates. Then we have 2, 5. Then we have your 5, 10, 7, 2, 9, and I think this is 8 or 7. Okay, 9, 8. Okay. So this is your scatter plot. Try this as well. Okay, Saurabh, got a message. Okay. So this was your scatter plot. Like this, we have many other plots. Another one is your bar graph. Bar graph, bar plot. So you have this same function. So we take the same list, or you can change it as well, but you can have the same list. Just type in ELT.bar x comma y. So up till now, you were seeing that we have these points. When we have the bar graph, we have this entire coverage will be there. So we will have bars over here till this point, for this one till this point, till this point. So whatever points that you have in your scatter plot, you can just correlate. This is how it appears in your bar graph. Try this. This is the initial level data visualization. We have some even interactive visualizations where you can plot and where you can even interact, or you can change something within the data, the plot that appears. So a lot of powerful visualizations are there. We also have many other libraries, but for a beginner level, we wanted to introduce you to Matplotlib, where you can work on your own graphs. You can even customize these graphs. You can change the color. You can even write the names for the different axes that we have. A lot of facilities are available in Python. We cannot do all of this in other programming languages with so few lines of code, which makes Python very popular as well as a very powerful language for processing data, for working with data. So after seeing the line plot, the scatter plot, and the bar plot, the next, let us check how can we use it in combination with NumPy. So we can have np.array, and we have two values, 0, 6, and over here we have 0 and 250. So we only have two data points. So the one of the point is 0, 0, and the other is 6, 250. You can just plot it using plt.plot x points, y points, and it will show you a straight line. So we are just connecting the 2 points. Okay. So you can also use So all of these libraries that we are discussing today, all of these are interconnected. Okay. Next, we are also going to see what is a pie chart, a pie graph. This is also available in Python. So you can have your NumPy array. You can just declare your own NumPy array. And we write the statement plt.py, and we pass that array to this function. Again, like other graph functions, we are again invoking plt.show. And with that, we can have our own pie chart. We can also include some other numbers and see. So the changes are reflected. We have the proper pie chart over here. We can also customize it. We can add the names as well. So next, we have the way we can add the labels to a pie chart. So we can have another list, my labels, containing the labels which we want to assign to each of the section. Like for 35 apples, 25 bananas, 25 cherries, 15 dates. Again, we use plt.py. We pass y, the numpy array. And there is a parameter within the function called labels. To labels, we assign our defined labels. So we have the list, my labels. We assign it to the labels parameter of this function py. Again, we can call plt.show. And it will give me the pie chart annotated. So now if I want to have another one, and I add kiwi, I can do that. Okay. Okay. Next, we'll also see how we can assign labels to the different axes. So for that, first we have two data lists. So in this list, we have declared it as numpy array. It contains a list of values for x-axis and for y-axis. Next, we are using the plt.plot xy. So it is creating the plot. After that, we are customizing the plot. So to customize, we use two functions are there, x label and y label. So when we use the x label function, we can specify what is the label on the x-axis. What label do we want to appear on the x-axis of the plot? So here we have written average pulse. You can write anything. So like just values at x, you can write. And plt.y label, we have given another name. Now when we execute this function, you can see that we have a plot, and on x-axis we have average pulse, on y-axis we have calorie burn. Okay. So not just x label and y label, we have many functions we can use to customize the plots. Next, we can also set the title. So like plt.title will help you to set the title of your plot, which will appear on top of the plot. Like here we have sports watch data, average pulse, calorie burn. Similarly, we can also customize the font. I'll share this notebook with you. You can go through this. So we have the font types as well. We can specify it like a dictionary, and then we can apply that font to the title, the X label and Y label. So here you can see it's appearing as a different in a different color as well. So here we have specified it as blue, which is why it's coming as blue, the other as dark red over here. All these things you can apply to your plots. Okay. So that summarizes our study on different libraries. Next, I'll introduce you all to your mini projects, the suggestions that we have. So,
Devolina, I think we'll take a break for 5 minutes.
yes, sir.
For the mini project, we should have separate recordings, which is not going to be uploaded. Okay,
Okay.
so that's why I want a break from all of the students. You have to join it again. Okay, just after 2 or 3 minutes, you have to join. Okay, then we'll
Okay,
start
sir.
this mini. Okay, thanks to all. Bye. Just join after this. Okay.
Okay, sir.